Bismillahirrahmanirrahim. Assalamu alaikum and welcome back to my channel. Today I will be performing different functions of on quarters software, and for this, first of all, I will be doing arithmetic operations, simple arithmetic operations of plus, minus, multiply, and divide. So first of all, let's see the code. First of all, we would be starting with modules as it is the syntax, and ending with n modules. Then inputs would be declared that we have two inputs, and output would be the logic, how many logic operations we would be doing. Logic operations would be in the matter of eight bits, and the inputs would be in 4 bits. So first of all, for the input bits, we would be declaring from 0 to 0, like it is from 0, so the gap would be 4. And for the outputs, we would be 7 to 0, that would be 8 logics. So first of all, we would be assigning it that A is equals to A plus B, that way A multiplied by B, that would result in 36. And we would be certainly seeing ahead that how this input is declared. I've already solved this problem, so I've just taken screenshots that I could explain it as easily and as quickly. So first of all, this would be our code. We would simply be changing the signs and the outputs here, and we would be declaring them, and we would be seeing the results ahead. The major tasks would be done in the graph in the waveform portion, and that would be explaining us that how these inputs are defined. Here I've written as one comma b1. This means one bit which is whose value is 1, and here it is b. So let's see the module. This would be the graph. This would be circuit produced when we would see in the RTL. And let's see what we did. This would be the waveform. Now seeing the waveform, what we did, this was the waveform that we've given, and this is the result that is implemented. If we have to get given A is 12, B is 3, then we would getting 3 is equals to 36, and 4 is equals to D is equals to 4, E is equals to 15, and DF is equals to 9, and G is equals to 1. That is giving the absolute correct implementation of this circuit. Okay. After this, as we have proved arithmetic operations, we would be saving ahead, and we would be doing logical operations. Logical operations graph would be like this that we have produced, and saving ahead. Okay, so this is the code with the logical operations. With logical operations, we would be giving 3 inputs and 5 outputs with both of with the output and input both with 4-bit operators. Then we would assign that if A is and B, we always put double and. This is the logical operation, and then we would be putting A is or B, and if A is not equals to A, so A is not or is equals to B, so B is equals to or is equals to C. We would be seeing the implementation over here, and these are the results that implemented over here. So we have given the inputs, and this is the output that we have been evaluating. I have explained that I have given as A is equals to 2, B is equals to 0, and C is equals to UX. Then what is the value D, E, F, G, H? So first we would be saying the D is equals to 0 if A is and 10. So A and 2 are not common, so this will be B is equals to 0. This would be 0 implemented. Then E is equals to 1. That is also the correct answer, high logic. Then F is equals to 0, that is low logic, and the circuit is correct. The answer is correct, and G is equals to 1 logic, and X is equals to X logic. F is equals to X logic because of the C over here. So this is also the correct logical operation that is implemented. Now then we have done, and then we would be doing. Then after this we would be seeing the logical operations of this. As you can always see over here that we have implemented an 8-bit operator of A and 8-bit operator of B, and we have not is equals to it is not equals to A. Then this circuit will be implemented with 8 inputs, You can also take over here. I've taken 8-bit operator, but you can also take 1-bit operator, 2-bit operator, 3-bit operator, 4-bit operator, as you wish. But as I wanted to implement a circuit with the 67 as input, so I wanted to see what will the output be. So I've implemented as 6 inputs, but you can take it according to. So this when we 60-bit 67, we give A input as 67, the B input will be 0. So this also the circuit is correct. Then I've also taken this. We have done multiple of examples over here to show that what would be the logical operations, if the logical operations are correct or not. Then we would be. So these are all examples that I've done in certain places. Now we would be doing rational functions, relative functions. So this is a function we have now. We would be we would be using different operators, and we would be saying that how this input would be seen. So we have given 4 inputs and 4 outputs. Like if A is smaller than B, and if A is greater than B, uh, if A is greater and equals to C, if A is D is greater or lesser than C. So the smaller lesson, see then how would be the implement it would be implemented. This logic gate would be circuit would be implemented. So this logic circuit, as you can see over here, then we would be implementing different values of A, B, and C of of all these inputs, and you would be seeing its logical operations on the outputs. And as you can see, they are all implemented. So after this relative function, we would be using equalist equal function. So equal function we have inputs 1, 2, 3, 4, 5, 6 as in needed in equal inputs, and output will be a both 2. So first we would be saying that if A is equals to B, this is an equality. This is an equality sign, and case of equality, and uh, over here explaining this, I would be showing you how these circuits would be working. So first, right on, I will be showing you the equality sign. So this this operation this operation of equality is logical equality is logical equality. This is not equality or case equality, and this is case inequality, case out equality, case equality, logical equality, case equality, logical equality, and logical inequality. This is logical equality, this is in logical inequality, this is case equality, and this is case inequality. So we would be seeing them over here. The circuit I implemented, and I would be showing you. This would be the circuit reduced. With circuit, we would be seeing the operations. By seeing the operations, we must be looking for seeing the operations. I've entered a few values of a few integers, and we would be seeing the results, and the results implemented would be like this. So let's see. The next it would be equitest. We have already done that. I have shown you equalities one. And this is an example also done by me in order to explain explain it further. This is also explaining it. So after this, we would be doing. After this, we would be bit width function. As you can see over here, we have all operators like this operators and not operators and operators or operators. This negation operator, XOR operators, XOR, XNOR, or negation. This all would be seen over here. So first of all, we have done implemented the circuit. We have seen we have put the inputs. We have put the outputs. We have taken the different outputs, and we would be seeing the negative functions. First is the negative one. Negation. First is the negation. That is also we would be implementing the circuit as an OR gate, not gate. Then we have saying AND gate. This will be representing AND. This will be representing OR. This will be representing X or XOR, and this will be representing XNOR operation. So let's see the results and output. So with this, this is so this is the circuit of Vitruvius. This is a greater circuit, a long circuit, and after this, this will be the output implemented over here. Then after this, after bitwise, we would be going to the reduce reduction operators. We have AND gate, a not AND gate, that will be NAND gate, then that is NOR gate, and then is XOR gate, and then XNOR gate, and etc. These are the reduction operators that we would be using over here. So first of all, we same the inputs and output would be declared when as the following sequence of the syntax. Then we would be assigning that if AND gate and of E, then what will be the result? Then E of or of B, then not of um, then XOR of B. So we would be implementing all of these operators, and we can represent furthermore to know that what would be the result. So this would be the circuit implemented if we have three inputs, and the output I would be done. So if I've changed, I've given the inputs of A, B input, the values of input. This would be the results would be found over here by seen by the waveform. Okay, after that there is shift test, and now shift test where it would be over here. Okay. Now shift test would be explained over here. So shift test would be explained over here. This is the circuit that we would be taking as shift left. After this, we would be implementing the shift functions over here. We can see that shift is equal to shift. For shift, we would be using these operators. And first, we were saying that if A is shifted towards the left, this means that 1. If A is greater, is smaller than 1. And if A, then we would be saying if A is lesser than 1. So this implementation circuit would be produced. Now let's see the graph. So graph, the waveform would be like this. I have implemented that if a value is equals to 1 0 1 1 0 1 0, then the output would be resulting as if a is shifted towards the 1, and this resulted output would be seen, and if it is shifted towards the 2, this output would be seen. So this is correct output. So after the shift function, we would be taking as the context function. So here we have used for this one. I've implemented the same circuit I just produced, that if a the comma between of them and 1 is the circuit, uh, not two semicolons over here. So this was the graph of this would be some RTL viewer would be showing this function, and for this is A is related to both, is common in both of the values, so it would be in the middle, and then I have implemented the values, and after they implement given the input values, they have given the output. I have received the output. Then for the next one, then for the next is replicate function. Replicate function will be if A is 4 times C is 4 times A. So this would be the circuit, and I have simply for this circuit I have simply given the inputs, and this resulted would be output. Then after this replicate test number 2, I have also changed the circuit, and I've changed the values from 2 to 4. Like I've implemented the value of B, and I have given the value of C is implemented the value of C, and C I've given as for A, then what would be the resultant output? This would be the structure formed, the way RTL picture, and this freeform would be formed if I put the value of E. Just given the value of A, I can implement the value of rest of the values. So and V value of B. So after that implementation, I've done few exercises also over here and seeing the results over here regarding different operators and functions that I've discussed in this video. So I hope you like this video and thank you very much. Shazak.